Alright, so right now I'm in chapter 2, which is the linear motion chapter, speed, velocity, acceleration, stuff like that. So the one thing for speed that you need to remember, well, really the only thing for speed that you should remember, is that it is just a number. A number, and sometimes we refer to this as a scalar. That is, it has no direction, it's just a number. And in the problems that I looked at in this book, for average speed, which is in page 12, you have to remember the formula, which is, so average speed equals total distance covered divided by the time interval. That is how long it took to cover that distance. And you can look at the example that they had in chapter 12 in order to understand it. It's a very, very simple idea of what average speed is. They give you the distance, say 240 kilometers. They give you how long it took, say 4 hours. So if it's 240 kilometers, which is the total distance covered, and it took 4 hours, then the average speed would be 60 kilometers per hour. That's it. Nothing magical there. Now remember, velocity is not a scalar. Velocity is a magnitude and a direction. So they're going to give you how fast it's going and to which direction, like west or east or north, things like that. They're going to give you a direction and they're going to give you the speed. Oh, and remember, constant velocity is a straight line. When velocity is not changing, it is just a straight line. Because the speed isn't changing, is not changing, and the direction is not changing either. So for something to have a constant velocity, the speed needs to be the same and the direction needs to be the same. If you do have a changing velocity, it's either because the speed is changes, or the direction changes. And for this one, for the changing velocity, remember the circle. If you're traveling along a circle at a constant speed, you are still changing velocity, because at first, say we start here, we are first going, say, west, and then we're going south, and then we're going east, and then we're going north. So our direction is changing, but our speed is different. But our speed is constant, and that is why the velocity is changing. Either one of these needs to be changing, or both need to be changing in order for you to have a changing velocity. And if you do have a changing velocity, that means that you have acceleration. So acceleration, we usually denote this as an A, is equal to the changing velocity divided by the change in time. So how fast it was going and at whatever direction, divided by the time it took to travel whatever distance. So for you to have acceleration, you need to have either a changing speed or a changing direction, or both. And that that's pretty much it. So remember, in terms of, for the example, remember this one, the circle one. Even though you have a constant speed, you're still changing directions, which means that this object traveling through this path has an acceleration. It's accelerating. When you are accelerating in a straight line, so say your velocity is increasing in a straight line, then you can find the acceleration by just the change in the speed divided by the change in the time, or the time interval, or how long it took for you to travel that path. Say for example, you traveled at a speed of 10 kilometers per hour, and it took you 1 second to travel that fast, then your acceleration is 10 kilometers per hour per second. Well, right, it's time second. Sorry. Because this is, let me erase that so you can understand what I mean by that. But I mean, it's not a good way to write it. Okay, so let's say it was 10 kilometers per hour divided by, and it took you 1 hour to travel that at that speed. So then your acceleration is 10 kilometers per hour squared, because these multiply. Why do they multiply? Well, let me rewrite this differently. This is actually 10 kilometers per hour divided by 1, or multiplied by 1 over 1 hour, right? Because this is 1 over 1 hour, so hour times hour is hour squared. Okay, so it is 10 kilometers per hour squared. Alright, so that's acceleration in a straight line. You finally end chapter 2 with the idea of a free fall. Remember, in here, for the free fall, our acceleration is gravity. Okay? And we want to know how fast we're going at a given instant. All we have to do is find the acceleration. Well, sometimes they give you the acceleration. So for how fast, that is, what's the velocity, the instantaneous velocity? That's just velocity equals the gravity times the time that you are looking at. They're going to ask you, how fast is an object going at time 2? Well, then it's just going to be 2 times, and then gravity is usually 9.8 meters per second, or sometimes they round it out to 10 meters per second. So that's just going to be 20 meters per second. So that's more or less how you would how they would ask you a question about how fast something is going on a free fall. They could also ask you how long it took to travel in a free fall, and for that one we're just looking for a distance. So distance, or d, is equal to 1/2 times the acceleration. Now the acceleration could be gravity, or if we pushed it, it could